Hello again. Hopefully you answered these questions and got some good answers. We'll come back to this at the end of this video. So, in order to multiply matrices together, they have to be of a proper set of dimensions. Okay, so looking up at the top, it says the inner dimension, in order to multiply two matrices, the inner dimensions must be the same, and your answer matrix will be the size of the outer dimensions. So looking at this example here, we're multiplying A times B. Okay, A is a 2 by 3 matrix. We are multiplying it by a 3 by 1 matrix. So when you organize it this way, this is matrix A, we are multiplying it by matrix B. The inner dimensions must be the same. Okay, just put them in order, A times B. These dimensions on the inside, those need to be the same in order to do matrix multiplication. If they're not the same, you cannot do this multiplication. All right, so these are the inner dimensions. They are the same. Okay, so we can do the multiplication. The answer matrix, when we multiply these two matrices together, we're going to get an answer matrix called A times B. The size of this answer matrix is the outer dimensions, 2 by 1. So AB is going to be a 2 by 1 matrix. That's the idea of the outer dimensions. So every time you go to a problem and want to multiply two matrices together, you have to check the inner dimensions to be able to even know if you can do the multiplication. If the inner dimensions are the same, great, you can do the multiplication. The answer is the size of the outer dimensions. All right. So always have to check that. Now, the steps to do matrix multiplication. It's a little bit different, and this is the best way to word it. This is the wording from the textbook. What you do to find the entry in row I and column J of the answer matrix, the A times B, you're going to find the sum of the products. That's the key phrase. You are adding up the products of the corresponding entries in the row and the column. All right, the rows of A, the entries in row I of matrix A, and the entries in column J of matrix B. Everything with matrices is row by column. So we're going to add up the products of the entries in the row multiplied by the entries in the column. Okay, seems a little bit weird. On page 226 of your book, in example 1, they got a nice color-coded look at it. I'm going to try to manipulate that same, not manipulate it, but do the same thing with this example. So, I want to do A times B. Again, you have to check the dimensions. Matrix A is a 2 by 3 matrix. Matrix B is a 3 by 1. Inner dimensions are the same. The answer matrix, AB, that's going to be a 2 by 1 matrix. So there's going to be 2 rows and 1 column. All right, so to do the multiplication, what we are looking for is matrix AB. This entry is row 1, column 1. Remember the address notation. So for that entry, we are going to take the entries in row 1 of A and multiply them by the entries in column 1 of matrix B. You're going to do all these multiplications, and then you're going to add them up. You go entry by entry. So we are going to take first entry in the row, 2, multiply it by the first entry in the column, 3. Then we're going to add and go to the second entries in the row and column. So -1 times +1. This -1 is the entry in the row, second entry in the row, multiplied by the second entry in the column, plus. Now we go to the third entries. Third entry in the row is 3 times third entry in the column is 2. Okay, these are the products of the corresponding entries. We are adding them up. So we get 6 plus a -1 plus 6, that is 11. This is your entry in the answer matrix, row 1, column 1. So that equals 11. Now we're looking for the entry change colors here. We're looking for the entry in matrix AB, where this is the second row, first column. So again, we're going to take the second row now and multiply it by the second column. You go entry by entry. So first entry in row times first entry in column, plus second entry in row times second entry in column, plus third entry in row times third entry in column. And we add up all those products. So we've got a 12 minus 2 plus 0, that's 10. This is our entry into matrix AB of the second row, first column. There's our matrix multiplication. Okay? So this is how you do it. It's not just multiplying one, corresponding entries like we did with addition or subtraction. You got to go row by column. You multiply your corresponding entries in the row times the corresponding entries in the column, and you add up all of those products. All right? It's a little bit different. It takes a couple times of practice, and you'll get that practice when you do the homework. Don't forget to go to the book. You got a couple of extra problems with the try this, so you can practice these things. Look at that example 1 in the book on page 226 to see how they worked through it. They did a different dimensions matrices, but the process is the same thing. So use the resources that you have. Now this question on the bottom, can you find matrix B times A? So matrix B was a 3 by 1. Matrix A is a 2 by 3. Can you multiply these things together? You should all be saying no, because those inner dimensions are not the same. You can only multiply matrices that have the same inner dimensions. All right, so back to this example. Find and interpret A times B. So in that first video, you really did matrix multiplication, all right? And after we get through doing just the plain old multiplication of this, you'll see that you're getting some of the same numbers. So first off, can we multiply A times B? A is a 2 by 2. Matrix B is also a 2 by 2. Inner dimensions are the same. Our answer is going to be a 2 by 2 matrix. So this is not necessary, but to me it is helpful. All right, I'm looking for an entry AB, first row, first column. I need an entry for the matrix multiplication AB of the first row, second column. Now this is the second row, first column, second row, second column. By doing this, it kind of helps me guide, okay, I need to be multiplying this row by this column. So the first entry, one that goes in the first row, first column, we are going to take the first row, multiply it by the first column. So we're going to have entry by entry, 4 times 30 plus 6 times 15. That's 120 plus 60, 90. And that is going to equal 210. All right, now I'm looking for this first row, second column, A, B, 1, 2. So I'm going to take the entries in the first row and multiply them by the entries in the second column. So it goes 4 times 29 plus 6 times 10. 4 times 29, that's going to be 116 plus 60, so 176. All right, change colors one more time. Now just going entry by entry here, I'm looking for the second row, oops, AB, second row, first column. Okay, so now I'm dealing with the second row of matrix A, and I am going back to, that was pretty neat, going back to the first column in matrix B. So entry by entry, 2 times 30 plus 4 times 15. We get 60 plus 60, that's 120. And now our last entry, in matrix AB, second row, second column. So keeping the second row in matrix A, now I'm focusing on the second column of matrix B. So we're going to go entry by entry, the same as before. 2 times 29 plus 4 times 10. And we get, what do we got? 2 times 29, 60, 58, plus 40. That is a 5, not a 3. Lousy board. For a total of 98. So, our answer is this matrix, AB. We have first row, first column, 210. First row, second column, 176. Second row, first column, 120, and then 98. Okay, so these numbers should look familiar to what you found in that first video. Now, just to put some context to this, the interpret part here. When you do matrix multiplication, the inner dimensions must be the same. So, it's always row by column. Those are the titles for the row. These are the titles for the column. I spelled it. All right. For matrix B, those are the titles for the row. These are the titles for the columns. So when we do A times B, the inner dimensions must be the same. And they are. Regular cab, dually, dually. Okay, inner dimensions are the same. Our answer matrix are the outer dimensions. The outer dimensions are the first matrix A rows and matrix B columns. So when we go to our answer matrix A times B, the rows, that was the tires and doors. The columns was this up here. Number made on the first shift. This was the second shift. Okay, so to interpret this 210 answer is the number of tires needed for the first shift. It's 176 tires for the second shift. For doors, you need 120 for the first shift and 98 doors on the second shift to make all those tires. Okay, and again, those numbers should match up with what you did in that first video. All right, that is it. Fantastic. I'll see you in class on Wednesday. Have a good day off.